So today we have to talk about how to find the definite integral for a piecewise function. Let's see this example here. Evaluate an integral from 0 to 3 for f of x. If f of x is x squared when x is less than 2, and 3x minus 2 if x is greater than or equal to. So here now, the integration of f of x dx from 0 to 3. Since we have 2 here, which is a disconnect point, so we will say that it is from 0. We will start from 0 to 3. Here we have 0 and 3. So we will put this 0 here and this 3 here in the second integral. Then since 2 is a disconnect point, so I will say from 0 to 2 and from 2 to 3. Is it clear? From 0 to 3. 2 is this point here where the functions are changed. So from 0 to 2 and from 2 to 3. This is the first point. Then I will ask myself, which function should I put? If I'm talking about from 0 to 2, so did I am talk about x is less than 2 or x is greater than 2? If I am talking about the interval from 0 to 2. So is it x less than 2 or x greater than 2? Yes, grade 11. Less than 2, bravo. So I will choose this function, which is x less than 2. So I will put here x squared dx plus, and from 2 to 3, so I'm talking about x greater than 2. So I will use 3x minus 2. This is the first step. Then I will continue as I know before. First, I will integrate, then I will evaluate. Now,
teacher,
x squared, yes?
teacher لما بنعمل 0 from 0 to 1 هي بس from 0 to 3 يعني؟
From, sorry?
هلا مش هي 0 from 0 to 3 وعملنا
Yes, okay.
from 0 to 2 و from 2 to 3
Okay.
بدنا نعمل 0 to 1
No, لأنه هي عند only you have that point 2, the disconnect point.
okay.
يعني I mean you have from 0 to 3. Before that, when you are like before, like yesterday, or we to integrate from 0 to 3. From 0 to 3, you have the same function. Here, no, here at point 2, from 0 to 2, we have the function which is x squared, and at point 2, the function is changed. It will be 3x minus 2. So to integrate this interval from 0 to 3, you have first to integrate from 0 to 2, then from 2 to 3. Because at point 2, the function changed.
Okay, thank you.
Then, so first I will integrate x squared, which is x cubic over 3 from 0 to 2, plus the integration of 3x, it will be 3x squared over 2 minus 2x from 2 to 3. After I integrate, now I will evaluate. Let's evaluate first the first one here. We have 2 to the power 3 over 3 minus 0 to the power 3 over 3. Then plus 3 times 3 squared over 2 minus 2 times 3. This is for the first. Oh, this is for F3. Let's write it here first. So let's integrate and evaluate up because I need a space. So let's write it as x cubic over 3 from 0 to 2 plus 3x squared over 2 minus 2x from 2 to 3 So as I told you, first you have to find for the first one, which is 2 cubic over 3 minus 0 cubic over 3 plus, let's find now here f3 minus f2. So at point f3, what did we have? We have 3 times 3 squared over 2 minus 2 times 3 cubic then minus, let's find now f2, which is 2 times 2 cubic minus 2 times, 3 cubic minus 2 times 2 cubic. Then 2 to the power 3 is 8 over 3 plus 3 squared 9 times 3, 27 over 2 minus 3 cubic 27 times 2, 54 minus 3 cubic 9 times 2, 27. 27 times 2 will be 54 plus, and because here I have to multiply minus times minus, 2 cubic 8 times 2, 60. Then this can and this cancel each other. Then here let's say by 3, by 3, by 2, by 2. Then, so we have 8 times 2, which is 16 over 6 plus, let's multiply now 27 times 3, which is 81 over 6 plus 60. 8 plus 1 is 97 over 6 plus 60. Let's simplify it now, which is 16 also. So the answer will be 32.1. This is the integration from for f of x from 0 to 3. Is it clear?
Yes, teacher.
Do you have any question, or shall I go to the second one?
Teacher, why did you cancel the 54 with each other? They are negative.
Oh. So here. I forgot that we have negative sign before. So it will be negative 54. Wait, negative 54 minus negative 54
Negative 108
plus 16. So it will be negative 92. And here before that we have 97 over 6 minus 92. We have it as negative 75.8. Thank you. This is the final answer. Let's solve another one here. A function f of x is defined piecewise on an interval. In these exercises, use the theorem 4.55 to find the integral of the f of x over the interval. Here now, the interval here I have from 0 to 1 and from 1 to 2. So let's find it as the integration. Let's now solve number 25. Here f of x it has an interval from 0 to 1 and from 1 to 2. So the integration for f of x from which interval? From 0 to 2. I will take the least point and the greatest point. So from 0 to 2 for dx. Here I have from 0 to 1. It's like this. I have from 0 to 1 and from 1 to 2. From 0 to 1, the function is x, and from 1 to 2, the function is x squared. So to find the definite integral from 0 to 2, I will say that we have from 0 to 1 plus from 1 to 2. Is this clear?
Yes, teacher.
Then after that, from 0 to 1, what do I have? I have x. And from 1 to 2, I have x squared. So let's now continue here. The integral of x, it is x squared over 2 from 0 to 1 plus the integral of x squared, it's x cubic over 3 from 1 to 2. Then let's evaluate here. We have 1 squared over 2 minus 0 plus 2 cubic over 3 minus 1 cubic over 3. So we have 1 over 2 plus 8 over 3 minus 1 over 3. Let's find it as 1 over 2 plus 7 over 3 . So 3 plus 14 is 15 over 6. So let's simplify it as over 3 is 2 over 3 is 5. So it is 5 over 2. This is now the final answer. Is it clear?
Yes, teacher.
Yes.
Let's solve now number 26. Number 26 here. In number 26 here, we have to find the integration from which interval? What is the interval?
From 0 to 4.
From 0 to 4, thank you. Which will be from 0 to 1 and from 1 to 4. So from 0 to 1, I'm talking about square root of x. And from 1 to 4, I'm talking about 1 over x squared dx. Then after that, here, square root of x, I can write it as
X to the power half.
x to the power half. And 1 over x squared, I can write it as x to the power negative 2. So I simplify them now to integrate. Then let's say that they are x to the power half plus 1 over half plus 1 minus 0 plus 4 to the power negative 2 minus 1 to the power negative 2. Then x to the power I'm sorry. Here we have x to the power 3 over 2 over 3 over 2 from 0 to 1 plus x to the power -1 over -1 from 1 to 4. So x to the power 3 over 2 over 3 over 2, I can write it as 2 over 3 square root of x cubic. This is for the first one here. So let's write it as 2 square root of x cubic over 3. And the second one here, I can write it as -1 over square root of x. Then, let's continue now. 2 square root, let's find, evaluate from 0 to 1. So we have 2 square root of 1 over 3 minus 0 minus -1 over square root of 4 minus -1 over square root of 1. Then, which is, what did we have here? We have 2 over 3 minus -1 over 2 plus 1, which is half. And here we have 2 over 3 minus half. Or we can use the butterfly way. So what did we have? 4 minus 3, 1 over 6. This is will be now the final answer. Look at them now. Is it clear?
Teacher, why is it minus?
Which one?
In the orange, in the middle, it's minus? Why? Shouldn't be
Here?
plus? Yes.
Yes, it's minus. ولا plus. صح
طب
plus. Okay. لا. I'm sorry, I cannot. Okay, it's a plus and continue, please. Who can?
It's okay.
I know. I erased the slides by mistake. It was x to the power 3 over 2 times 2 over 3, we said before, and here we write it as square root of x cubic from 0 to 1 plus -1 over x squared x minus, it was -1 over x from 1 to 4. Okay, so this continue now. It's as 2 over 3 square root of 1 plus 0. Sorry?
Not square root of x. -1 over square root of x.
It was x to the power 1.
The power -1, so it will be x.
It was -1 over x. I write as -1 over square root of x.
Yeah.
That's my mistake, because it was 1 here, 1. Oh, x to the power -2. So when integrate it, it looks to the power -1 over -1. So it's -1 over x. That's it, without square root of x. So my solving was wrong. So let's continue here, or let's repeat them here as from
Teacher,
-1.
when we flip it, the 1 will stay negative.
This one here? Yes.
Yeah.
But
Okay.
yes, it will stay negative. But the exponents, it will be positive.
Okay.
So from negative 1 to 4 minus negative 1 over 1. So it is 2 over 3 minus 1 over 4 plus 1. Now, or before that, here, let's solve it as negative 1 over 4 plus 1, which is 3 over 4. So we have 2 over 3 plus 3 over 4 times 3 times 3 times 4 times 4. So we have 8 plus 6, 14 over 12. This is the final answer. Now if it's 9 plus 8, no, 9 plus 8 is 17 over 12, which is 1 and 5 over 12. Is it clear? Did you find any mistake now? Is it clear? Is there any mistake?
No.
No, teacher.
I hope. Yeah. Now, let's talk about now how can we find the total area. To find the total area, we have to find the absolute value for f of x from a to b dx. So when I'm asking you to find the total area, you will take the function and you will put it between absolute value. Let's have this example here. Find the total area between the curve y equal 1 minus x squared and the x-axis. So here, let's say that this is the interval. I draw them from negative 1, 0, 1, and 2. After drawing, it's going to come like this. It's like this, here, and here. This is after drawing. Now, the total area, so from this word here, the total area, don't forget that I have to put the function between the absolute value. Now, between the curve, look at now, I want now to see where's the shaded area between the curve and the x-axis. So I'm talking about this one. Then over the interval from 0 to 2. So this one here, I don't want it. I want only from 0 to 2 between the function and the x-axis. So if you look at it here, this is this function here. It's hard to solve it by geometry. So I need to find the total area here by the fundamental theorem of calculus. We have to integrate the function, which is 1 minus x squared from 0 to 2. Is it clear?
Yes,
Yes.
teacher.
So to find the total area, I have to put the function between the absolute value. Then between the curve of 1 minus x squared and the x-axis, between the over the interval from 0 to 2. So I have to know which area should I find its area, which region should I find its area. Now after that here, so I want to find now the integration of 1 minus x squared from 0 to 2, and I have to put it now between the absolute value. Now, between the absolute value here. Why did I put it? This absolute value, it's work like the piecewise function. That's mean at point 1 here, as you see, the curve will change. It was from 0 to 1 upward. Then from 1 to 2, it has another shape. And it will be on the negative x-axis. So that's why I have to say it is from 0 to 1 and from 1 to 2. Is it clear?
Yes, teacher.
Yes, teacher.
Then after that, from 0 to 1, is it on the negative y-axis or positive y-axis?
Positive y-axis.
Positive y-axis. So here, since y it is positive, so I will put them here as 1 plus x squared. That's positive. And from 1 to 2, it is in the negative y-axis. Is it right?
Yes, teacher.
So that's why I will say it's negative 1 minus x squared. So this 1 minus x squared, it could be positive from 0 to 1 and negative from 1 to 2. That's why I will put this absolute value, because all of us know, if I'm told you the absolute value of x, that means x, it could be x and it could be negative x. To find or to say that the answer is x. Here, that's why 1 minus x squared, it could be positive and it could be negative. From 0 to 1, it's positive, and from 1 to 2, it's negative. Is it clear?
Yes, teacher.
Yes,
Then now,
teacher.
let's integrate. 1 minus x squared. When integrated, we have x minus x cubic over 3 from 0 to 1 plus, let's simplify now this one here, negative 1 plus x squared. So we can write it as x squared minus 1. So the second one here, it will be x cubic over 3 minus x from 1 to 2. Then now, let's evaluate here. Let's start with this part here. What did we have? We have 1 minus 1 over 3 minus 0 plus 2 to the power 3 over 3 minus 2 minus 1 to the power 3 over 1 minus 1. 1 minus 1 over 3, which is 2 over 3, plus 2 to the power 3 is 8 over 3 minus 2 minus 1 plus 1. Since now they cancel each other. So here 2 plus 8 is 10 over 3 minus 2 over 1 times 3 times 3. So we have it as 6. 10 minus 6 over 3, which is 4 over 3. This will be now the total area for the curve, or for the area between the curve of 1 minus x squared and the x-axis over the interval from 0 to 2. Is it clear now?
Yes, teacher.
Okay.
Yes.
Tomorrow now we will continue here how to find the integration for the absolute value of 2x minus 1 from negative 1 to 1. What we have to do here without shaded area, at which point should I disconnect? Yani here I told you at point 1, from the graph, you know that at point 1 you have to change the function. Here I have, since we have an absolute value, so I have to change the function, but at which point you have to find it. So tomorrow, inshallah, we have 4 examples. We have to see how can we find the integral or the definite integral for a function if it has an absolute value. Okay? If the function has an absolute value, how can to find its integral? Before that, here, so it has 1 minus x squared. To find it, what we do, we say it's from 0 to 1 and from 1 to 2. Why the function here changed and at 1? Because let's find the 0 value. Oh, here's the 0 of y. Y equal 1 minus x squared. So what did we say? We say at point 0, the 0 function here, or the y in the x-intercept. So y is 0. So we say equal 1 minus x squared. When you now factorize it, we have it as 1 minus x times 1 plus x. So here x, it could be -1 and it could be 1. What does that mean? That means the function changed at point -1 and at point 1. But at point -1, I didn't, it's not important to me. I need only at point 1. So that's why I changed the function at point 1 and I said it is from 0 to 1 and from 1 to 2. So that's, inshallah, tomorrow I will repeat it. I will tell you now tomorrow at which point here we have to solve, or at which point we have to solve the integral, and why here, as I told you, we solve it, or we know why at point 1, because of the region here, the shaded region. Tomorrow we will know how to find the y-intercept. At this point, the function will change. One, it will be positive, and one, it will be negative. Which one it will be negative and which one it will be positive, tomorrow I will tell you how. Do you have any question now?
No, teacher.
Thank you.
You are welcome. If you have any question, kindly tell me
Thank you,
tomorrow.
teacher.
You are welcome.
Thank you, teacher. Have a nice day.
Thank you. Bye bye.
Bye.
Bye.